Good day, fellow. Today we are going to do the electromagnetic waves calculation. Because now, bear in mind that last time I still remember I said to you that electromagnetic waves. Waves, they consist of what? Of electric field as well as magnetic field that acts at 90 degrees to the direction of the wave. Another thing that you must bear in mind is that all electromagnetic waves are light waves. Somehow they consist of what? Of photons. The word photon is a packet or the quantum of energy. The packet of energy. Each and every light or the ray of light, it is made up of what? Of photons. Photons. Then how now do we calculate the energy of that photon? We use this formula EHF, whereby now E represent what? The energy of a photon. We also have H, which is a Planck's constant. It is always equals to 6,6 3 times 10 to the power minus 34 joules second. Then we also have the frequency, which is measured. This is our frequency. The frequency, hope you can see there. Frequency, which is measured in hertz. Then energy, joules. Bear in mind that for all electromagnetic waves, the speed of light is always 3 times 10 to the power 8 meter per second. You see, it is always 3 times 10 to the power 8. And I just want to highlight something, that frequency can be written in a form of speed of light, which is 3 times 10 to the power 8, as well as divided by the wavelength. You see, I wanted to highlight that concept. Then now let us try to do some problems. Let me erase everything for us so that we can be able to do some problem or the applications. Okay, let's say now, if we come across this question, which state calculate the energy of microwave with a frequency of, let's say we have a frequency of 5 times 10 hertz. How are we then going to calculate the energy of what? Of the energy of microwave. The energy of microwave. It's so simple. Let us try to take out our data. First, we have what? Frequency, which is 4.5 times 10 hertz. We know that H is always 6,63 times 10 to the power of minus 34. See, they want us to calculate what now? The energy. Do you still remember the formula of calculating the energy? It is like this: H F. You see, do we have H? Yes, we do have H, which is 6,6 3 times 10 minus 34 multiplied by 4.5 times 10 hertz. Let us take out our calculators. I don't have a Casio, I have this one now, but let's see. We have 6.63 times 10 negative 34, 4.5 times 10 to the power 10. Then we get 2.98, 2.98 times 10 to the power of minus, let me see, minus 23 watt joules. You see, it's so simple. It's so simple. It's so simple to answer these questions. Now, what I'm going to do is, I just want to highlight something before I can even proceed with you guys. That okay, let me just write here. I just want to highlight something. Let's say if we had some wavelength of, let's say, 2 nanometer, or I just want to make an example, 2 nanometer as well as 2 micrometer, and they say to us convert the following 2 meters. We all know that our wavelength, it is measured in meters. Then how are you going to work this thing out? Check. So simple. Always bear this in mind. For nano, you always multiply by 10 to the power of minus 9. Then it's going to be meters. Then for micro, you always multiply by minus 6 meters. You see, micro, it's minus 6. Nano, it's minus 9. It's minus 9. Please, guys, don't forget this. Don't forget this. Now, let us try to answer this question now. Let me erase everything. Erase everything. Okay. Let's see if they now ask us this question. See now, calculate the energy of gamma rays with a wavelength of, let's say, 4 times 10 to the power of minus 14 meters. Then let us take out our data. We don't have energy. We do have H, Planck's constant 6.63 times 10 to the power minus 34. Then do we have frequency? Nope, we don't have frequency. But we know that frequency can be calculated using this formula. You see? Do we have the speed of light? Yes, it's always 3 times 10 to the power 8 divided by the wavelength they gave us already, which is 4 times 10 to the power minus 14. Then we almost have everything. Let us go and substitute now to this formula. C, frequency. You see, you can change this frequency to be C over, as I've already done it there. Then now you can just substitute almost everything to this formula, which is going to be 6,6 3 10 minus 34, speed of light 3 times 10 to the 8. You divide by your wavelength, which is 4 times 10 to the power minus 14. Then let us take our calculators and try to determine the answer. Okay, I have now 6.63 times 10 minus 34. Okay, also have 3 times 10 by 8 divided by 4 times 10 minus 14. Hopefully I didn't make any mistake there. Then we get 4. Let me check. Let me check if I did it correctly. Let me repeat it to see if I didn't make any mistake. It's 10 is to the power minus 34. Oops. We have 3 times 10 power 8. Okay. Divide by 4 times 10 to the power minus 14. Okay, then yes, indeed I get 4,97 times 10 to the power minus is 10 to the power minus 12 what joules. You see, I wanted to clarify that. Then okay, that's it, we're done. Enjoy.